Hello and welcome back. In the last video in this series we put together all the parallel sets, and in this video we're going to do the series connections. Before we start, I'll remember to put in a disclaimer. This lithium-ion batteries are considered dangerous goods. They can catch a fire if you do something wrong. So if you plan on making your own batteries and modifying your own EV system, I would advise you to watch all the videos in this series, and if there's anything you don't understand, make sure you do your research and you know everything before you start. As you said, we have the parallel sets done, so I can pull them all apart in individual packs. You see, I have 13 packs here, and if you remember back in the beginning, I said if we stack the packs, so this is the negative and this is the positive and this is the positive, so I'd have to stack the packs basically like that. Thirteen of them. That will be a long skinny battery, so we put them together more like this. Now what I'm thinking we should do is, okay, so I'll take these two. Now, I could have put this battery all together all at once, because it is a little more difficult to get them lined up this way. I need to get all of those little tabs to go in on both top and bottom. I can do it, but it is a little bit more difficult, and it would be easier if I put the thing together complete at first. But for the sake of this video, I'm doing it this way. You see, I've got the connection done really well here now. And we have negative and positive. So I have a strip here someplace. I'm going to take a negative, a nickel strip, and put across here, and that way these two cells will be joined in a series. You didn't really see the way I done the other one, so I'll try to. So I got it made like that so that it. Am I bleeding? Looks like I'm bleeding somewhere. Anyway, that's okay. So that will connect on these cells, and then that last piece would extend it there, right? I take my little buddy here. Get my foot in the right place this time, so I'm not looking for it when I actually go to do it. I had to reposition you because the hands was in the way. Put those out of the way. Now, so you see this top, this part is thin strip all the way across. Down here we've got an empty spot. So to get the power out of this, full power, if we go, you're going up through these two, across this continuous nickel area here, and down through these, then I should, if I put a load between these two, I should get 7.4 volts and what is it, 49 amps. Okay, so 7.4 volts and 49 amp hours if I put a load between here and here. So now that's the first pair. Let's take the second pair and put them together. Not the easiest thing to do, but it's doable. And you need to know exactly why you're doing what you're doing, so I have to do the video this way. Otherwise, I've failed you. Remember that one piece that I put out on the end? There. I've got it. I just need to take another piece and put on there like that. And I'll have that pair done. Now I have 6 pairs plus the one set. The tops are all done. The bottoms have a space. So let's take these and turn them all up like that. Do I need one strip or two? We'll find out here now. That will prevent any accidental crossing of these. So, because we got this upside down now, we kind of got to turn things around. Make sure I've got it lined up right. Of course, I got the positive there, so it's got to go this way. And putting these together will be the same as there. Not need to. That would be nice if they all just fit together nicely. But it looks like I'm going to have to cut the tab on every one of the single pieces. Okay. Yep. Now I'm not hitting right on the batteries, I'm hitting on the plastic in between the batteries. Okay, and I'll put this last one on. Let's turn it back over. All of these empty spaces there, you can see where there's neither join. They're not supposed to have joins. So I'm going to do the same thing on this side. Yeah, technically, one easier. None of that. This is mostly just for me, so as soon as I look at it, I can tell where the connections are. Gotta put this one here a little different because reasons. You'll see when we get there. Flip this back over again because now I need to do these connections. So I've got all of the series connections put together now, and I had to take off this piece of tape here anyway, again because reasons. So we've got a gap right here. This is the positive end of the battery. You can see that it's positive by looking at the top of the battery cells there. And then down here we've got a gap right here, and this is the negative end of the battery cell. Because we got a gap here, the electricity has to go down through, and on the bottom we've got a linkage from this negative over to this positive, so it comes up through here. Then we've got a link and a gap, so it goes across, down, up, down, and so on, all the way across your battery, right? Now, if I put this together right, this multimeter should show me 48 volts. What I do, take the negative end and put it against the negative on the battery bank, and take this positive end and put it up here, and it gives me 52.1 volts, which means these are not quite, I think it's about 54 volts when they're fully charged. Now if I go across each single one, I have to turn the battery up on edge actually to do that. I'll turn the battery up on edge so I can do each one, because, okay, so I set my negative against the negative here again and test across this battery. And I got .0. There's a negative, and then the next positive is down on this side. This is why I had to turn it up. 8.0. Then we go up to here. We've got 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, and 52. I can put these back on afterwards, these little strips. I need to take it off. I made a mistake, eh? And when I put the second one together, I put the clips on the wrong side, the series connection, and I had to cut it off again, this series connection here. When I went and bought more of the nickel strip, I bought the 0.2 millimeter, realizing that my spot welder was doing so well with the 0.15. So it can handle, well, optimum is 9.6 amps. Now, 9.6. What I've got, of course, like I say, this is the positive end. We've got a space. We've got a negative and a positive, and it's joined across here with one layer. I have 7 spaces for it to go across. Each space, 0.2 millimeters, can handle 9.6 amps. 9.6 amps is optimal, I should say. So if we multiply that by 7 we've got going across, we've got 67 amps. Now that's good enough for me, but in the sense I'm doing it, I might as well make this pack here so it doesn't have to be picked at again if somebody was wanting to put on a BMS that took over 67 amps, maybe even the full 112. They'd have to take the battery right down to this point if I didn't add here now. Because I can, I think it's better for me to put on a second layer on every series connection. Now I put those couple pieces of tape back on there just for safety's sake. And so what I need, I could, if I add some of this that was 7 millimeters across, 0.2 millimeters thick, I could just cut little pieces and stick across the actual series join. But because I have this and it's easier to do it this way, I just need to count my 7 joins. 1, 2, 3, 4, 5, 6, 7. And cut off the other side of that. This doesn't matter if this one is too short. What I'm going for is just these 7 cross members is what I need here. So if it's too short, like I said, it doesn't really matter. And it doesn't have to be exactly positioned actually, but for aesthetics purposes, I can do that. better turn you up a little bit. So I'm still going over the top of the batteries, but in reality I don't even have to put these welds right over the battery cell. Instead, what we can see here is that the two batteries, so you got 8 amps from this one, 8 amps from this one, we get 16 amps running across here. And this being 0.2, 9.6 amps, and 9.6 amps is 16.7. Very easy. I have to do that now with every one of these series connections. And then we'll come back for the next step. So, what I noticed was that I'm taking the leads and I'm resting this arm on the battery, but every now and then, especially when I touch this outside one, and then my wrist is resting here on the metal over here, I can feel a little bit of a shock. Not much, it doesn't hurt, it's just a little tiny sting of a shock, because I've crossed out from here to here. So I went and got some craft foam, got some over right there, and I'm going to do that so that I don't cross out the battery. And then see, because in the beginning I would do it like this, and then I'd get a shock, put the initial bit on. I have all of these series connections doubled up now. This is the negative, and now when we get down to the ends on the battery itself, like I say, I just need 2 layers at most. But when we're pulling the power off for a load, then all of that power is going to come down into the 1 or 2 wires that's going to be sticking off here. Right? Now, usually most of what I've seen was people, they would solder a heavier wire onto this end, and then it would just come right off. I can't figure out the soldering. Soldering just doesn't work for me. So I am the nod. Now there's a few ways I could do it, of course. I can spot weld some of these on. So what I would do if I done that would be already shocked myself a few times on there. But anyway, I would attach, I'd cut this piece off, I'd attach that on. I could run 2 wires through there, crimp it on, and then spot weld it onto the battery. So that was one idea. And you know what? Let's try that first, because I do have another thing here to try afterwards. If that doesn't work, let's mock something up. How easy is it to get those ends off, I wonder? I'm going to have to clean up. There's parts missing, but that broke off fairly easy. So these are not as good as the one I just had. But at any rate, now let's see how we're going to do this. I could put it on just like that. Well, didn't turn on record, so I've got to redo this. So the little round piece on the end, I'm going to open that up because reasons. Flatten that out. Flatten that out. We'll do it this way. Now, I want to spot weld these little connectors onto here. To do that, I'll have to lay that on there. They don't have to be exact, but fairly close. It didn't fit go on exactly for this bottom part. So I'm going to flatten that a bit and try this again on this part right here. Now it attached. So we've got that piece spot welded on, and I'm going to do the other two before I even start. What did I use to flatten that just then? Seems like it's a good idea not flattening off this part where the other connector connects to it, just the part that I opened up. So that back end part. Okay. Now, let's is a little more difficult because I have to see, I've got to spot weld through the nickel strip because I can't spot weld through the actual connector, but I can spot weld the nickel strip onto the connector. I gotta make sure that each one is actually spot welded on. Now this bottom one I'm going to have to turn around because otherwise that end piece will be hanging off the end. Okay, so I've got the 3 done. Now I can zoom you out. Now this is just a regular household wire, 10-2. So I'm going to take this one. According to Google, these wires on short distance, so it's 15 amps power transmission. So if you're wiring your house or a extension cord or something like that, right? 15 amps, but chassis, so if you're wiring up a car or as we're doing a battery in a e-bike, then you can do up to 55 amps on a single strand. So you put in 2, 55 and 55, of course that's 110, isn't it? This is copper wire. So I can put them on like that, and I can crimp them now and twist this wire out at the end. I could spot weld it on. It's a little too far away. Let me turn this battery around so you can see what I'm doing. So you can spot down there and have your connection off right here, whichever one you want to do, either the flat connection or the rounded one, what these came out of. The problem I'm seeing with that is that these wires, they can bend and move. So if it does, then I've got a problem of this copper wire could break. But I just thought of a different idea. Well, that would be good. I don't think I want to do it that way. I've ummed and ahed over that for a long time. Which is why I bought this. Now what I'm going to have to do, I think, is that, I'll show you now. Out of that metal piece, I need to cut something that's going to come down the center here and give me two starts. So let's see. Something that will sit there like that. Whereby two of these would go on there. I have one there and one there. I can put on two wires. That way, with a 60 amp BMS, I can just put on the one wire, and if I change the BMS to a 80 or 100 some higher BMS, then I could put on two wires. So essentially I'm cutting two pieces out of here that looks like this. So now I've got two, because I got two ends of course. I'm going to cut that out. Now don't forget, if you're going to make one of these, see all the burrs sticking up on that? That has to be all smoothed down. These tabs especially have to be nice and smooth. So I'm going to clean that down with the Dremel. Now, oh, a little bit off. Now that one fell off. It's because that metal is a little too thick for the way these come. So I had to open them up a bit. There. That one's not tight enough. Nice and snug. Two tabs. And it's going to go onto the battery this way. That's going to be my power withdraw. I'll be able to put two power wires on there. So that if I was running like I am going to, I'm going to be running a 60 amp, a 30 amp BMS. It'll max out at 60 amps. So I'll only need to put on one wire. If I were to change it up to a more powerful BMS, then I would have to put on a second wire. So it needs to sit there like that, so that these pieces can slide all the way on. Now, in order to do that, I could put it over the top, and I could put it on the bottom. I think, actually I don't know what I think. Because if I put it on the bottom, I'd have a piece there like that. I'd basically put a piece sticking out either side. But if I put it on top, I'd still be doing the same thing. I don't think it makes any difference whether or not I put this piece on top or bottom. So I'm going to put it on top because it's easier. So what I'm trying to do now is I have to put that large piece right where it is. So I'll position it. I'm being very awkward here now. Don't know what's up with that. Anyway, I finally got it positioned. And stuck on. Good. And for aesthetics' sake, I want the diagonal piece. Now I've got it well attached there. So I'm going to bend it down. Wonder if the pliers would make a sharper curve. So that's an heavy duty bus bar for the end. Now, the reason I'm putting these back on here oh, I got to cut off this little bit of hin there. It's out too far. Just like that. Now it's attached. That thing hasn't been... Make sure you got this final bus bar attached down good. Now this is the one I attached. Let's get a new one that's not expanded and see if it'll slide right on. No, it won't slide on, see? So the best thing to do is just expand them a bit, and then when you put them on, crimp them back on. I have a second one here. See, I need to expand them a little bit to get them to go in. So just take a small screwdriver and push down in there so far. It's not easy, so the first try you probably bring them out too far, and then of course you have to compress it back. The chances that you'll get it just right is very slim. So that was pretty good. What I'm not liking, let's see if I turn up the power. Doesn't see, it's not holding on this outside part here. Now what have we got? That's out down there pretty tight. So that's my negative connection. I'll take this battery, turn it around, turn it over, and as you can see, now I've got to take that off of there so that I can put this one in this way. Just like that. And I think this time I'm going to make sure I've got the full length of the batteries. That would be easier, wouldn't it? Like so. Oh, this piece out on the end there. I didn't do this outside one there. It's got to go right to the edge. Now put it up there. That ain't moving. And the series connections are done. Remember, okay, so with the series connections, you have to make sure that I've got 7 spaces. It has to be able to take the power from these, from one full parallel pair. So each cross member would have to do 112 divided by 7, which would give you 16.7 or some number like that. But because the optimum, the acceptable is 9.6, then I had to put on 2 layers across the series connections. I don't have to do that with the parallel connections because across the parallel connections is at most 8 amps going across there. The next step, I need to make a connector for each. I need to make a connector for each of these series joins. When we put our BMS on, because this is the plug side of the BMS, and we've got a black wire that we need to connect to the negative end of the battery, and then we have 13 of these red wires, one for each of the series connections, and you go along on the path. So from the black, this will be your first series connection, second series connection, third, fourth, fifth, sixth, 7, 8, 9, 11, 12, 13. 13 red wires and 1 black. I'm planning on putting the little connectors on it, so I need to put a connector on each one of these. For that, the little flat connector will be sticking off like this, and then I'll plug the other one into it. We've got 6 per side, plus the positive on this end and the negative on that end. So we've got 14 in all to do. I already have 1 done. See, it goes plugged on like that. So to do those, you cut down one side of that with the wood burning tool, because it's hard to do it with the scissors or knife. Okay, so take this piece. If I push the screwdriver in the end, and then I got it opened up. So the Bill Nose pliers, will work to straighten those right out. You see, I got it straightened out now. So, battery's in the way again. I've got my little piece. You need something hard to hit it on, of course, to make that perfectly flat. I need to get a piece of metal. It's going to be a nice bit wider than the tip, than this end. Let's test that. It's on nice and tight. And what I'm doing, this is the series connection, and I'll put the tab part that I'm going to connect the BMS to right out into this part where that the one battery comes in that way and the other one goes out, so there's a little bit of an indent. And where I put the strip on, I'm going to have that on top again as well. It's on there nice and tight. And now I just got 2 done, so I guess I got 12 to go. So now we have this entire thing put together with the proper connectors. I'll turn this up on edge and take off this connector. And now you see with the little connectors, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So now, ideally, you see this is the negative power end right here, I should be able to touch with my multimeter. Take it and touch this one, the negative end, and then use the red one then. So here's the negative. I could just, yeah, I could just put that in there like that. Turn on the power. I should be able to touch each one of these now and get, first there's this one, which I get 4 volts. Then I touch this one, I get 8, 12, 16, 20, 24, 28, 32, 36, 20, 40, 44, 48, 52. Gotta plug that in. I got all the power used up. But we've done well today. Thank you very much for watching. We've got this put together now. This is the main battery bank. We've got parallel connections done. We've got our series connections done. We've made sure our series connections were thick enough to carry the maximum load that this battery might put out. We put on strong bus bars on the end to make sure we've got something that could take a full 112 amps. And we've got all the little connectors. These don't need much current at all. They're not, it's just enough to test the voltage. That's all the BMS is doing for these connectors. So we've got these connectors in, and in the next video we'll wrap this up and we'll put the BMS on. Once again, thank you for watching, and hope I'll see you in the next video.